Hi, this tutorial provides a brief introduction to the 3D viewer included with CloudCaster Lite. First, select your desired model. If that model is on a web server, it'll take a few moments for the data to stream down. In this case, it loads directly off the hard drive, taking only a few moments. If your project is published to removable media, it will also only take a few moments to load your point clouds. Now that we have the model loaded in the space, to rotate the model, you simply left click with the mouse and drag. If you want to zoom in and out, you hold the Shift key with the left mouse and drag. And to slow down your movement, you can hold the Z key to slow your rotation, zoom, or pan by a factor of 10. To pan the model, you hold the Control key and move with the left mouse. In addition to rotating with the mouse or otherwise interacting with the mouse, CloudCaster Lite comes equipped with a number of standard 3D views or cameras. You can access these in two major ways. You can right-click in the view space when a model is loaded, or you can use the view panel. The view panel is activated by clicking the view button at the top right. Once you have your panel open, you can click in the background and drag it anywhere you want. That applies to all panels in CloudCaster Lite. So we're going to go through a variety of standard 3D views. First, we'll look at a top view. Anytime you click any of the 3D views, your model should automatically rotate. You also have the choice to toggle your camera between perspective and orthographic modes. And the viewer supports a number of isometric or standard 3D views. Besides these standard 3D camera views, CloudCaster Lite includes a number of other navigation tools. The one we like the most is Inspect New Point. You simply click the Inspect New Point button, choose your point in the model, and that becomes the new center of rotation, and the model is moved to the middle of the screen with that point being at the center. You can now zoom in and out, rotate the model, and everything will happen around that specific point. The pivot point in the CloudCaster Lite viewer by default fades out after 5 seconds. If you want to keep it on, you open the settings panel and check the show pivot point box. You can now see your pivot point at all times. To remove it, uncheck the box, and in about 5 seconds it will fade out of the viewer. Besides the Inspect New Point tool, we have Fit Model to Screen, and we have Go to Default View. The default view is the view that the publishing user set when publishing the project. Going to default view ensures that you see the model exactly as the original author intended. You can access the default view by clicking in the view panel or right-clicking. Finally, if you need very precise control over the orientation or zoom of your model, you can directly enter the desired values in the status bar. This is a bit tricky. You have to double-click in the desired field and not move your mouse. Then enter the values you desire, click Enter, and the model will move accordingly. If during this time you move your mouse off of the field, the values will not be entered. Example, type in 35 degrees. I'll move my mouse out and it reverts to its original value. You can control your zoom factor, your camera's field of view, your yaw, pitch, and roll, all by direct entry in the status bar. We're now going to cover measuring distance in the CloudCaster Lite viewer. To access the measurement tools, you click the measure button to open the panel. The standard workflow for measuring points is to first click the Inspect New Point button and to find the general area you intend to take your measurements. We're going to zoom in now and we'll take a few measurements around this window. Because I don't like the distortion that happens as I move the model, and that's a function of the camera's field of view, I'm going to make the camera field of view much smaller than it is now. And you'll note as I rotate the model, the distortion is much better. So now that we've zoomed into the area we wish to measure, we'll go ahead and take a few measurements. To measure your first point, you'll click the Pick Point button, and then you'll click the desired point in the model. Each time you click the Pick Point button and click a 3D point in the model, the CloudCaster engine attempts to find the nearest 3D coordinate within 3 screen pixels of your click. If you click a point in the model that does not have a 3D coordinate within 3 pixels, your pick point action will fail, and I'll demonstrate that now. I'll pick a point out here. There's no corresponding 3D coordinate. The action fails, and nothing happens until I find a good point. As you click new points, a line with the distance value is snapped between the previous point and the new one. And as you move about the model clicking points, all the distances are listed in the view space, and you can zoom in and out, and they stay there. And you can actually put specific labels or custom labels for each of the pick points by simply clicking in the label field in the measure panel and renaming them. And you'll see the label updated to reflect our new name. At any time, if you're unhappy with your current picked point, you can click the Clear Last button, and it will remove the previous point. And you can do this a number of times to backtrack. Or you can click the Clear All button to instantly remove all measurements from the screen. We're now going to cover using the Saved View function. This works a little bit different depending upon whether the project was published with the personal edition or the commercial edition of the software. If your publishing author published the project with the personal edition, your Saved View function will be limited to the dimensions of the browser screen. However, I published this project with the commercial edition of the software, and so I can actually create very high resolution renders of my scene, including measurements. So what we'll do here is take a few measurements of a window, and then we'll generate a very high resolution render of the full model, complete with those measurements. So we're happy with our results. You can see the data is quite accurate despite my somewhat sloppy picking. The distance values are quite consistent between the left and right sides and the top and bottom of the window. Now that we're happy with this, we want to do a high resolution render and, for instance, share this with a colleague. So we're going to click the Save View button. Because we'd like to provide a little bit of visual context for these measurements, we're going to render a virtual camera frame much larger than the current browser. The current browser dimensions are 2514 by 1335. Using the commercial edition, your maximum dimensions are 4096 by 4096 pixels. That generates a 16 megapixel render. We don't need that much resolution in this example, so we're just going to say 3200 by 3200. I need to unclick the aspect ratio button. And now we'll click go. And the viewer is rendering the image on the fly based upon what was in the view space at that moment. But while the render happens at the top right, you can continue to interact with the model, and the render engine will do its thing in the background and let you know when it's ready to save your image. So we're going to clear all the measurements here, and we're going to go ahead and move to our next area of interest, take some more measurements and render those. And we'll save our earlier rendered image. And if you'll recall, we only had a small section of the model in the view space at the time of render, but let's take a look at our image now. And you can see we have a much larger virtual camera frame that was rendered based upon the dimensions we set. This is what we saw in the browser, but you can see we can pan through the model and we have much more information than was in the browser window at the moment of render. Using this technique, you can generate very high quality prints with measurements, using orthographic mode, or really whatever suits your fancy. And this way you can give very detailed information and share that with your colleagues or friends or whatever audience you have. Finally, we're going to quickly go through customizing your viewer interface using some of the settings here. We'll clear our measurements, and this particular model has this color data, but it also has some intensity data from the scanner, and you can toggle between the two simply by choosing your desired selection. Some models may or may not have color and intensity values, and in that case you will not be able to change this. You'll only have a single setting depending upon that particular model. You can change the background color of the viewer. You can directly enter any custom value you want, or you can choose from the included palette. And that's not a good color. You can turn off the axis triad and you'll see it disappears from the bottom left. Turn it back on. And you can also toggle the status bar off and on. When you do that, the screen resizes. Let me turn it back on here. And finally, you can choose to show the pivot point, and you'll see we get a yellow dot up here. That means that was the last point in the model that we were rotating or interacting around. And you can see as we move the model, it actually is centered on that particular point. It literally pivots right around the yellow dot. We'll turn that back off. And finally, you can control the sensitivity level of your mouse by using these sliders down here. As our final step today, we're going to go through the use of the pretty render function. This function is primarily designed to be turned on right before you save a view. It's very processor intensive and causes quite a bit of lag or delay on larger models. So it's really not designed to be left on at all times while you're interacting with it. So we're going to go ahead and zoom out a little bit, and we will switch into pretty render mode now. And by default you don't see anything, but when you slide the point size to the right, you'll now see it takes a couple of moments to calculate, and we'll get a silhouetting effect in the model. Sliding the slider to the far right increases this effect a little bit more even. And depending upon the model you have and the way the data is arranged, the pretty render effect can produce quite nice results. Sometimes it produces not very nice results, but it's up to you. And once more, our typical workflow is to zoom in, find the view we like. We want to do a save view, but we want to render that with the pretty render mode. So we're going to slide it all the way to the right as our last step, since it takes a bit of time. Now we'll render. Now we can turn the render mode back to normal. Move our point size all the way down. And we're now free to navigate as we wish as the render completes. We'll save this. And you can see the image was rendered with a silhouetted effect. In the future, we'll be adding quite a number of additional visual effects to the CloudCaster engine, but for now, the silhouetting effect is all we have. If you have any questions about using the CloudCaster 3D Viewer, do not hesitate to give us a shout. Support@onlineinteractivesoftware.com.